Hi scholars, so we're going to look now at equations that have two variables. So we're going to consider the equation 3x equals 6y, and just so we keep track of our variables, let's put them in a different color. So 3x equals 6, and we'll use blue, 6y. Alright, and now equations in two variables follow the same principles as equations in one variable, right? Up to now it's just been solve for x, or get a alone or get b alone, right? But just because we have two variables doesn't mean anything changes. So let's take a look at what we mean. So let's solve the equation for x, okay? So we start 3x equals 6y. And if I had said initially solve the equation for x, what would you have done? If I said, for example, 3x equals 12, what would you have done? Well, divide by 3, of course, right? Use inverse operations. We can divide both sides by 3 to get x equals 4. And we're going to do the same thing here. We're going to divide both sides by 3. Divide by 3, divide by 3. That cancels, and we are solving the equation for x. We're getting x all alone. X equals 6 divided by 3 is 2, and the y is still there. X equals 2y, and we're done. That's it. Okay? Now, let's solve this equation for y. Well, same idea. I have 3x equals 6y. And now, I want to get y alone, right? My goal is to get y all alone. What's in the way? 6. How can I get rid of 6 times y? Yeah, the inverse operation, right? Divide it both sides by 6. Right? So we can divide both sides by 6. 6's cancel. That's really nice for us. We end up with a y equals, and 3 divided by 6, well, that's really just 1/2, right? 3/6 is the same as 1/2, and I can just put our x, right? I can bring down our x right here. So 3 divided by 6 is 1/2, and the x just drops right down there. And this is our answer here. Now, do these two answers make sense with each other? They do, right? Here we're saying that 2 times y gives me x, right? That means that x is twice as big as y. It makes sense that if I have x and I take half of it, I will get to y, right? And we can actually try this with numbers if we want, right? We could say, for example, that we could just to experiment to make sure this makes sense, we could say that 6 equals 2 times 3, right? So if x is 6, y is 3. Is that true here? If we do 1/2 of 6, do we get 3? You bet we do, right? 1/2 of 6 certainly is 3. So this is just a numerical example. This is a numerical example just to explore, right? To make sure that what we're doing actually makes sense. And it's a good practice in general. If you're a little confused with what's happening, there are too many variables, you can plug in a number and just see, does it make sense? Okay. Now we want to solve what is the value of x over y. Okay. It's going to be the same idea. In this case, instead of solving for x equals or y equals, we want to end up with something like x over y equals some junk, right? That's our goal. Well, if I have x, right, in order to get x over y, I'd have to divide by y. Let's do it. Let's divide both sides by y. So here on the left side, I have left over 3x over y equals, and look, the y's cancel on this side of the equation, right, equals 6, and we're done. Now, right, my goal is to get this quantity x over y all alone, right? That's my goal. And what's in the way? If I view this as one thing instead of two things, instead of x and y, I view this as one whole object. What's in the way? 3. So what can we do? Let's divide both sides by 3. Let's do it, right? Look, the 3's cancel. X over y equals 6 divided by 3, which is just 2. What is the value of y over x? Well, we can do it in exactly the same way. We'll just do it really quickly here. Now, I want to end up with a y over x. So instead of dividing by y, what do you think I'm going to divide by? That's right. Let's divide by x. In this case, our x's cancel. I'm left with 3 equals 6 times y over x, right? But remember, y over x, I want to view this as just one object. This is one thing for me that I want to isolate. So 6 times the thing that I want, right? And how do I get rid of the 6? Well, right, they're multiplying, so let's use inverse operations. Divide both sides by 6, and these cancel, and we end up with y over x, right? We end up with y over x equals 3 divided by 6 is just 1/2, okay? Now there are some similarities between these 4 answers. I encourage you to explore them. Okay. Now let's take a look at some of these questions. So we have the statement, and this is now a statement in 2 variables. 4 times the quantity x plus y, right? This is the product of 4 and the product of 4 and the quantity x plus y. So this is one thing being multiplied by this whole other thing, equals 4x plus 4y. And we're asking again, is it always true? Is it an identity? Is it just some equation that's sometimes true, right? So that could be some equation, or is it never true? And we can see immediately, right? I can use the distributive property with 2 variables just like I did with 1 variable. So if I do that, I end up with 4x plus 4y equals, right? And here I'm just continuing on. I didn't touch the right side of the equation, so I'm just going to copy it down. Equals 4x plus 4y. Is this true? You bet it is. Is it always true? Of course, right? It's the same darn thing on each side of the equation. So this equation is always true. Let's take a look at one more. The statement 4 parentheses x plus y equals 4x plus y. Now a lot of students say, wait a minute, it's never true. Because, right, you say, I know how to distribute the left side of the equation. So let's do it. Let's just recopy it here. 4 parentheses x plus y. Does it equal 4x plus y? Or when does it equal 4x plus y? You say, I can distribute, and I end up with 4x plus 4y equals 4x plus y. And a lot of students will say, that's never true. Because these things match, right? Which means that these things should match, right? That's what initial way of thinking about it, right? If one thing matches, the other thing should match. However, let's just explore what happens if we keep solving this equation. Let's keep solving it, okay? So let's subtract 4x from both sides. I'm allowed to do it. That goes away. That goes away. What do I have left over? I have 4y equals y. Could this ever be true? It can be true, right? What number is the same as 4 times that number? The number 0. 0 is a number, right? I could explicitly show this by saying, well, let's subtract y from both sides. We end up with 3y equals 0. Divide by 3, right? If we don't see it immediately, of course we should see it immediately, right? Y equals 0. That's a real answer. That's a real solution. This is a solution. So the question of, is this statement, is this equation true? The answer is sometimes it is. In particular, when y equals 0, when y equals 0, this is true. This is true. Now, if y doesn't equal 0, it's not going to be true, right? Because when y doesn't equal 0, that's when these two things are going to be different, right? And when these two things are different, we're in trouble. But when y equals 0, we're okay, right? The equation is true. In fact, look, let's plug in, let's just see, does this actually make sense, right? Let's plug in y equals 0 in here. So if I have 4 parentheses x plus, what do we say, y equals 0? X plus 0, right? Let's substitute it. Does that equal 4x plus y is 0? Is that true? Right? Of course it is. Yeah, it's totally true. So this statement is true when y equals 0, and it is false all other times. Therefore, it is not always true, not never true, but in fact, sometimes true.